Hi everyone, we've reached our final destination. We're making video number 10. That means we're doing question 10 from the November 2023 question paper. If this is the first video you come across, where were you? Just know that there are 9 videos before this one. Just click the playlist on the description. It will take you straight to the playlist and you'll answer all the questions. You can answer all the questions with me. Just download the question paper and answer. If there are problems you come across or misunderstandings, please do write on the comment section. I'll definitely come back to you. Okay. Before siqala subscribe, but do. Okay, two small spheres A and B made of pure zinc are at rest and they are 0.1 meters apart on a wooden table. Okay, sphere A is negatively charged and is free to move on the table, while sphere B is uncharged. While sphere B is uncharged and fixed on the table, as shown in the diagram below. We are told that high intensity ultraviolet light of frequency 2.8 times 10 to the power 16 Hz is now shown continuously onto sphere B. The work function of zinc is 6.63 multiplied by 10 to the power negative 19 joules. Okay, this is the frequency of the light, guys. And please note that if the frequency of the light is higher than the threshold frequency, we will have an emission of electrons. Okay, the first thing we are being asked is to define the term work function of a metal. Work function of a metal is the minimum energy required to emit an electron on a metal surface. Okay, then 10.1.2, we are being asked to explain using suitable calculations why the ultraviolet light shown on sphere B will eject electrons from its surface. Okay, we know that the frequency of the ultraviolet light is equal to this one. If the threshold frequency will be lower than this frequency, then there will be emission of electrons, or you can say ejection of electrons. So how can we find out what is the threshold frequency? I know that my work function is equal to H multiplied by the threshold frequency. Remember that H is the Planck's constant. So my work function is equal to 6.63 times 10 to the power negative 19. All together, and my H is equal to 6.63 multiplied by 10 to the power negative 34. This is multiplied by the threshold frequency. So therefore, for me to find my threshold frequency, I just need to divide the two. 6.63 multiplied by 10 to the power negative 19 divided by 6.63 times 10 to the power negative 34. I'll simply get 1 times 10 to the power positive 15 Hertz. Okay, so the threshold frequency, guys, is 1 times 10 to the power 15, and the frequency of the ultraviolet is 2.8. So in this case, the frequency of the light source is greater than the threshold frequency, so therefore there will be an emission of electrons. All right, together. The reason is because the frequency is greater than the threshold frequency. That's why there's an emission of photoelectrons. Okay, sphere A carries a charge of negative 5.4 microcoulombs and requires a minimum force of 0.02 newtons to move from rest. Calculate the minimum number of photons of ultraviolet light that must strike sphere B, which will cause sphere A to move from its rest position. Okay, the first thing we need to do here, guys, is to calculate since we are given the force, we must calculate the charge on sphere B, and then you can simply calculate the number of photons. Are we together? So the number of photons will be equal to the number of photoelectrons. So I have 2-point charges, so I can simply resort to my Coulomb's law. K Q1 in this case is QA QB all over R squared. The force is 0.027. K is 9 times 10 to the power 9, and then the charge on A is simply 5.4 times 10 to the power negative 6. I want to find out the charge on B. The distance apart is simply 0.1 all squared, right? So for me to find the charge on B, I simply need to say 0.027 multiplied by 0.1 all squared is equal to 9 times 10 to the power 9 multiplied by 5.4 times 10 to the power negative 6. And then my charge, the charge on B will simply be 5.56 times 10 to the power 9 coulombs. Are we together? So now I do know the charge. I can simply calculate the number of photoelectrons transferred. So the number of photoelectrons is equal to charge all over the charge of one electron. So this is simply 5.56 times 10 to the power negative 9 all over 1.6 times 10 to the power negative 19, and this will give me 3.47 times 10 to the power 10 electrons. 3.67 to the power 10 electrons, right? And then now you're told that a beam of white light is shown through a cold gas. The emerging light is depressed with lines of with the line spectrum. Okay, but and the line spectrum is observed on the screen. Name the type of spectrum observed. This one, guys, is just absorption spectrum. It's just absorption spectrum. And then describe the spectrum in question 10.2.1. Okay, it will be just a continuous spectrum of the rainbow colors with dark black lines. That's how the spectrum will be. And then we are told that the diagrams below indicate some possible energy transmission made by the atom, right? Which one of the following diagrams could result in the type of spectrum observed in 10.2.1? Choose from diagram A to diagram B. This will be diagram A. Why? Because whenever the photoelectrons absorb energy, they will move from one energy level to the other. They will just increase in their energy level. So diagram B is the one that shows the one that indicates absorption spectrum. So guys, just guys, please do know that, guys, the chemistry paper is coming as well, and if you're not happy with but if there are things you don't understand in any question I've answered before, just write on the comment section of that video. I'll definitely come back to you. Thank you for your time, guys. God bless you.